Hello everyone, welcome again in Eng-Man YouTube channel. So again, we are here in Quick Knowledge playlist and we are at the 21st episode. And today's topic is, I think, quite interesting. It's about the causes of remaining oil. Okay, so I take a good message from a certain paper, and you can find the paper here, the price, what's possible. So it's written by Weber in 1999. Petroleum Geoscience, the journal, and this is the page. So this will be our main topic here, quick knowledge. So causes of remaining oil. If we start from OIIP, if I'm not mistaken, it's original or oil initially in place. All right, oil initially in place, or you can also call it OIP. All right, original oil in place. Okay, something like that, but it's the same thing. Let's start with the oil initially in place. The total amount of oil that we produce, ultimately, we call that ultimate recovery. And then what is left in the reservoir because of residual saturation, we call that oil as residual oil. Okay, so residual oil, the volume of residual oil is actually the volume of all oil trapped because of capillary trapping. And we call that as residual oil saturation. And then we also have some remaining oil, which is there because of it is just unswept. And we call that unswept oil. Okay, we have producing wells, we have water injection wells, but somehow because of many reasons, heterogeneity, and maybe insufficient pressure, low pressure, some oil will be unswept, will be unproduced, and we call that oil unswept oil. And we also have here, based on Mr. Weber, unproducible column. Okay, actually, if we want to know the definition of what unproducible columns mean, you need to go back to the paper. Okay, but we can guess here, sort of guess. The difference between unswept oil and unproducible column is actually unswept oil, it is there and we can actually produce that, but somehow because of pressure and heterogeneity, we cannot sweep that oil. But unproducible column is actually oil that is located in places which is very, very difficult to access. Okay, we somehow we cannot drill our new well at that column, at that zone, at that specific area, somehow, because of many reasons. All right. And we also have here unproducible depletion. Okay. Unproducible depletion. So what does it mean? Yeah, we can guess, maybe. We can guess here. And we can also check with our experience. Unproducible depletion. It is oil that is left because of to, you know, we cannot reach that area because of it's already very, very at low pressure. And because of it's already at low reservoir pressure, we cannot produce it because in our operations somehow we have high system pressure which leads to high wellhead pressure. So the well cannot lift the oil because of the reservoir pressure is low and the system pressure is relatively high, such that we cannot drain the oil and move it up to the surface. Okay, and you can always, you know, check it with your experience, compare it with your experience. So again, here we have initially original in or oil initially in place. All oil that we produce can be categorized in here. ultimate recovery. And oil will be left, some oil will be left because of residual saturation. We call that residual oil. Some oil is actually there, it's producible, right? But we cannot somehow move it. Our water injection does not reach that point because of heterogeneity, TIF zone, something like that, right? So it is unswept, it is undrained. So we call that unswept oil. And we also have unproducible column. Somehow we cannot reach that column, we cannot reach that zone. And of course, we cannot drain the oil there, and we call that unproducible columns. And lastly, unproducible depletion. We can produce at that area, water flood can somehow reach that point, but because of already the area has been already very, very depleted, very, very at low pressure, you cannot move it up from bottom hole to the surface. Okay, so we have 5 categories of oil, and let's focus our eyes on this unswept oil. So there are several reasons why we suffer unswept oil. The first thing is because of viscous oil. It's a no-brainer. If you have heavy oil, it is relatively more difficult to drain that oil, to move that oil from the bottom hole to the surface. Okay, so it's a no-brainer. Of course, if you have unswept oil, one of the reasons, of course, because of viscous oil. And later on, it will lead to mobility issue, right? And the second thing here, it's in its bold line. So I think Weber wants to make emphasis on this one. Large permeability contrast, of course. Okay. So if you have water flood, water injection, water will tend to go to the place with least resistance. And of course, the place with least resistance is zone with higher permeability. So water will tend to move in that zone, through high permeability zone, such that later on it will lead to unswept oil. It will lead to low sweep efficiency. Okay, so you will have some oil left unswept by the water. Okay, and of course, one particular reason is actually a large well spacing. If you make tight well spacing, if you make wells close to each other, maybe 100 meter, even 50 meters, right? It will give us more probability to drain as much oil as possible. Because of course, we have many points of drainage, points of drawdown, okay? So if you have large well spacing, the zone or the area well, between wells with large well spacing, it tends to contain unswept oil, okay? Because it lacks drainage from the closest wells. And lastly, because of poorly and not connected sands, of course, okay, in order to have a good sweep efficiency, you need good continuity. And if possible, you need low heterogeneity. So if we have large permeability contrast, it is like poorly and not connected sands. In this case, in poorly and not connected sands, somehow you have barrier with very, 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 very small permeability, which in other words, it's also large permeability contrast case. Okay, so large permeability contrast can also the same with poorly and not connected sands. Okay, large well spacing already clear, viscous oil already clear. We can also expand the issue of large permeability contrast. It can be local contrast, all right? Maybe you are close to a fault. There will be large permeability contrast between the fault itself and the matrix around your well, okay? Large permeability contrast can also occur vertically. we have tiff zones vertically, and we have, thin streak, tight streak. We have buffle, thin buffle, but with low permeability, vertically spaced, vertically distributed, although not continuous, and it can also occur areally, laterally, in covering wider area compared to this local case. So that's it for large permeability contrast. And poorly and not connected sense, it can occur due to fault, of course, you know, non-sealing fault, okay? Or I mean, sealing fault is of course the cause of not connected reservoir, and it can also occur not because of fault structurally, but more because of depositional or diagenetic control. Okay, something occur diagenetically, chemically long ago, so it creates somehow permeability contrast. It creates somehow, you know, permeability barrier that makes the continuity poor or poorly and if not at all connected sense. Okay, so all these problems will lead to remaining oil, which is not very good. And if you read this paper, one of the best technique, of course, to solve or to to decrease the problem with remaining oil is of course infill drilling. Okay, so I think that's all. I hope you enjoy this video. I hope this video is informative for all of us. Thank you so much for watching and see you again in the next quick knowledge videos. Thank you.